Okay, so in this video what we're going to do is we're going to look at the second derivative test in a case where f double prime of x equals 0 at a critical point, and in that case we're going to have to go back to use the first derivative test. So let's say, for example, we have f of x equals 3x to the fifth minus 20x cubed, and we want to use the second derivative test to find any relative extrema. So the first step we'll have is we'll find f prime of x and f double prime of x, right? So if we use the power rule on f prime of x, that gives us 15x to the fourth minus 60x squared, and f double prime of x equals 60x cubed minus 120x. Okay, so now what we're going to do is the same as the first derivative test, and we're going to find the critical values. So in this case we have f prime of x is 15x to the fourth minus 60x squared, and that's going to equal 0. All right, because 15x to the fourth minus 60x squared is never undefined. So to solve this, what we're going to do is we're going to reduce it to a quadratic polynomial by factoring out 15x squared, and that's times x squared minus 4, and that equals 0. And then I can factor that further, and that's 15x squared times x minus 2 times x plus 2 equals 0. And what that tells me is that for this one, x equals 0, this one, x equals 2, and for this factor, x is equal to minus 2. So these three things here are our critical values. Okay, so the next step in the second derivative test is going to be to check the sign of f double prime of x at the critical values. So let's do that. So the third step is we know that f double prime of x is equal to 60x cubed minus 120x, and we have critical values at x equals 0, x equals 2, and x equals minus 2. All right, so here's what we're going to do, is we're going to check each of these in the second derivative. So f double prime of 0 is equal to 60 times 0 cubed minus 120 times 0, and that equals 0. All right, so this case we can't use the second derivative test, so we're going to have to go back and use the first derivative test. Okay, and then I have f double prime of 2 is equal to 60 times 2 cubed minus 120 times 2, and that, if you plug it in, gives me 240. So since the second derivative is positive, that means our graph is concave up in this particular area, and this here, it means that we have a relative min. All right, listen, that particular region around x equals 2. So then at f double prime of minus 2, which is our other critical value, then we plug this in, and this ends up giving me minus 240. And this is concave down because the second derivative is negative, so this tells me that I have a relative max at x equals minus 2. Okay, so what we're going to do from here is we're going to go back and use a first derivative test at x equals 0. So for use the first derivative test at x equals 0. Okay, so I'm going to draw a number line, and I'm going to label minus 2, 0, and 2. All right, and up here I'm going to write the sign of f prime of x, and down here I'm going to write some test values. So we already know that negative 2 is at a relative max. There's a relative max at x equals negative 2, and there's a relative min at x equals 2. So the only thing we need to do is check the sign of f prime of x on either side of x equals 0 before we get to the next critical point. So here I'm going to pick x equals negative 1, and here I'm going to pick x equals 1. All right, so if I plug in to f prime of x, which is 15x to the fourth minus 60x squared, which we saw on the last screen, then f prime of negative 1 is 15 times negative 1 to the fourth minus 60 times negative 1 squared, which is 15 minus 60, which is negative 45. And I have f prime of 1, which is 15 times 1 to the 4th, minus 60 times 1 squared. And that's 15 minus 60, which is minus 45. All right, so at x equals 0, f prime of x is negative to the left and negative to the right. Okay, so since it doesn't change signs there, we can say that there's no relative max or min at x equals 0. All right, so now our final step is going to be to take the critical values that correspond to relative max and min, which are x equals 2 and x equals minus 2, and we're going to plug them back into the original expression. So here we have is for our original expression is we have f of x equals 3x to the 5th minus 20x cubed. All right, and then at x equals negative 2, we have f of negative 2 equals 3 times negative 2 to the 5th minus 20 times negative 2 cubed. And this ends up giving me 64. And this here is a relative max. And then at x equals 2, we have f of 2. And some of these are 3 times 2 to the 5th minus 20 times 2 cubed. Which again, if you plug that into your calculator, is going to give you negative 64. And so this here is a relative min. Okay, so when the second derivative is equal to 0, we should check the first derivative on either side of that critical value. And if it changes signs, then we'll have a relative max or min. In this case, it doesn't change signs, so there's no relative max or min there. So these are going to be 64 is our relative max, and minus 64 is our relative min.